Next, let's talk about magnetic forces on moving charges. So if you remember from our first chapter, we have Coulomb's law. And Coulomb's law checks the relation between force and the distance between the charges and then the strength of the two charges. So this was Coulomb's law. It means that there will be force when there are two charges Q1 and Q2 that is separated by the distance of r, then it will create a force. So that was Coulomb's law. So for magnetism, scientists made some experiments to check what is actually happening. What is the relation between the magnetic force and moving charges? So there are four characteristics of the magnetic force on a moving charge. The first one, magnitude of the force is proportional to the magnitude of the charge. So basically, F is proportional to Q. So this is almost the same as in electricity. But remember, for Coulomb's law, there are two charges. But for magnetic, only one charge will do. Magnetic of the force is also proportional to the magnitude of the magnetic field. So this is also proportional to V. Magnitude of the force depends on the velocity of the moving charge. So it means it is also proportion to V. This is the velocity of the moving charge. Velocity of moving charge lah. And finally, direction of the force is always perpendicular to both magnetic field and also perpendicular to the velocity. So from 1, 2 and 3, the magnitude of the force proportional. You can we have F is proportional to Q times B times V. And then scientists do some experiment. Finally, it is found that the magnitude of the force is actually F equivalent to absolute value of Q, the charge, times velocity times the magnetic field times sine phi. So Q is the charge. The charge is in modulus because this is just the magnitude. So magnitude must be positive. Even though the force is a vector, but the direction actually depends on something else. So let's talk about just the magnitude for now. So Q must be calculated using modulus, which is, so it doesn't matter lah whether positive or negative. V is the velocity of this charge over here. And then B is the magnetic field. Finally, phi. Phi is the angle between the velocity and the magnetic field. Let's see there for example. Okay. We have here two charges Q. The first charge is moving to the right and the second charge is moving to the left. And the magnetic field is also to the right. So that means that this velocity and magnetic field is parallel to each other. So what is the angle between them? There will be 0 because one is moving there. So this is V, and at the same direction there is also V. So phi is 0. So what is sine for 0? Sine 0. Sine of 0 degree is actually 0. So when we put here as 0, everything will be 0. So that's why they will experience no force if the charge is moving parallel to the magnetic field. What about down here? Down here, the angle is not 0. The angle is not 0 because the velocity, okay, let's talk about magnetic field first, is moving to the right. However, the velocity is moving to the left. So this is velocity. So the angle now is actually 180 degree. So sine of 180 degree is actually 0 as well. So if it is 0, then the force is also 0. So basically, when you combine these two together, we can just say that if the charge is moving parallel to the magnetic field, then it will experience 0 magnetic force. So this equation just gives us the magnitude of the magnetic force. What about the direction? However, the relation F equals to QVB sin phi is ambiguous on the direction of the force. If you remember the slide before this, the fourth property of the magnetic force is the direction of the force. It must be perpendicular to both the magnetic field and also to the velocity. So let's look at here. For example, if we have velocity in this direction and then we have B in this direction. So they are in the same plane. Let's look as if they are on a sheet of paper lah. So this is basically a sheet of paper. So the magnetic field is on the sheet of paper. The velocity is also on the sheet of paper. So what is the force that can take, if the force is must be perpendicular to both the B and also the velocity. So what direction can it take? Okay, let's just look at what can the direction be for the force if it's perpendicular to the magnetic field. So the magnetic field is towards the right. So let's say that just along the sheet of plane, this is we can say that force is along the sheet of plane towards up there. Let's say that maybe this is in X direction, so this should be in Y direction. Let's say that lah. However, even though now it is even though it is perpendicular to the magnetic field, it is not perpendicular to the velocity, because let's say that this is the angle between the velocity and the magnetic field is phi. Then this is 90 degree because perpendicular. That means that the angle between F and velocity is actually 90 plus phi. So this is not perpendicular with the velocity. So this is the wrong answer. So actually, the only way for it to be both perpendicular to the magnetic field and also perpendicular to the velocity, there is only two ways. The first is if it's going upwards, basically in Z direction. So here we have Y, here we have X, and Z is actually going upward lah, ke atas. Another way for it to be possible also it is going downwards. So I hope you can understand from this drawing, actually force and B, this is actually 90 degree to each other, because this is on the piece of sheet of plane, but F is going out of the paper. And also at the same time, this force, it is also perpendicular to the velocity. So it is both perpendicular to the magnetic field. Let me write down using the correct color lah. So this is its angle between the magnetic field, and this is the angle between the velocity. So I hope you can understand that it is actually 90 degree to both of them. So what does it mean by ambiguous? It means that F can be upwards or also F can be downwards. So there is actually a way of how to calculate which way F should be. Is it upwards or is it downwards, depending on the velocity and also on the magnetic field. Finally, if we have the velocity, if the velocity and magnetic field is perpendicular to each other, the force will be maximum, because for this one, the degree phi is 90 degree angle. So sine 90 degree is actually 1. So 1 is actually the maximum value for sine. So that means that for max, f of max, you should need the angle of velocity and magnetic field should be 90 degree. So this is the other way around of zero angle tadi lah. Zero angle means zero force. So highest angle meaning that also the highest force lah, means 90 degree. Okay, finally, another way of writing down the force from the magnetic force is F equals to QV cross product V. So we have F equals to QVB sine phi. This is in modulus. And then we have another way of calculating this down. F equals to QV cross product V. But don't worry, I'm not going to ask about cross product. This is just a knowledge for you. And if you know, and if in mathematics, cross product is actually A cross product B is just A times B times sine phi, where phi is the angle between A and B. So basically this is just mathematics. Tapi don't worry lah, be sure, usually in exam I will just ask about F equals to, if you know this one then it is fine. This is already enough for this class.